Good morning, students. The today's topic is electrochemistry. So in this electrochemistry, first we can discuss what electrochemical cell. What is this electrochemical cell? Electrochemical cell is a device. Electrochemical cell is a device which converts chemical energy into electrical energy, or vice versa, or electrical energy into what? Chemical energy. Electrical energy into what? Chemical energy. So this is called what? Electrochemical cell. This is called electrochemical cell. So the electrochemical cells are two types. The first one is galvanic cell. The first one is what? Galvanic cell. Or it is also called voltaic cell. And the second one is what? Electrolytic cell. Electrolytic cell. The first one, what is this galvanic cell? The galvanic cell, it converts what? Chemical energy into what? Chemical energy into electrical energy. Into what? Electrical energy by spontaneous redox reaction. What is the redox reaction? Oxidation and reduction is called what? Redox reaction. And the next the example for this galvanic cell or the voltaic cell is what? Daniel cell. It is what? Daniel cell. So this is what? Galvanic cell. Next second I can go for what? Electrolytic cell. What is this electrolytic cell? The cell, it converts what? Electrical energy. The cell which converts what? Electrical energy into what? Into chemical energy. Chemical energy. So this is called what? Electrolytic cell. Actually the electrolytic cell is mainly used for the manufacture of what? Sodium hydroxide by using what? NaCl salt. Okay, so this is the brief introduction about the electrochemical cell. Yes, now is what? Daniel cell. So what is this Daniel cell? So this is an example of what? Galvanic cell or voltaic cell. The Daniel cell mainly consists of what? Two electrodes. The Daniel cell mainly consists of what? Two electrode systems. One is what? The zinc electrode. And other one is what? Copper electrode. The zinc electrode is dipped in what? Zinc sulfate solution, and the copper electrode is dipped in what? Copper sulfate solution. And these two electrodes are separated by what? Salt bridge. These two are separated by what? Salt bridge. The salt bridge mainly it contains what? A saturated solution of what? KCl. So what is the function of this salt bridge? It avoids water, the liquid junction potential, and also it separates what? The two solutions. Okay, so this is the Daniel cell. Working off. Yes. Now the construction and working of what? Electrochemical cell. The example is what? Daniel cell. What is this Daniel cell? The Daniel cell is consist of what? Two electrode system. One is zinc electrode. This is called what? Zinc electrode. And it is dipped in what? Dipped in 1 molar zinc sulfate solution, 1 molar zinc sulfate solution, and this is called what? This is called what? Copper electrode, and this copper electrode is also dipped in what? 1 molar copper sulfate solution, 1 molar copper sulfate solution. So this zinc electrode is called what? Half cell. The zinc electrode is called what? A half cell. What is this half cell? This half cell is called what? Anodic half cell. This is called what? Anodic half cell. Why it is called anodic half cell? The half cell in which oxidation takes place. Oxidation is what? Loss of electrons takes place. So that's why the zinc electrode is called what? Anodic half cell. And next one is what? This the copper electrode is also called what? Another half cell. So this is called what? Cathodic half cell. This copper is called what? Cathodic half cell. This copper is called what? Cathodic half cell. Why it is called a cathodic half cell? Where the reduction takes place. Reduction means what? The gain of what? Electron takes place. Zinc is called what? Anodic half cell. The copper is called what? Cathodic half cell. So the half cell where the oxidation takes place is called anodic half cell. The cell where the reduction or the gain of electron is called what? Cathodic half cell. And these two electrodes means zinc electrode and the copper electrode, they are connected to what? They are connected to what? Emitter. They are connected to what? Emitter. They are connected to emitter. So here, so the next is when zinc electrode is dipped in what? Zinc sulfate. So this is a negative terminal with respect to what? Zinc sulfate solution. And this is the copper electrode is a positive terminal with respect to what? Copper sulfate solution. So here the zinc, it undergoes what? The loss of electron, or it undergoes what? Dissolution. Because of this dissolution, what happens here? The zinc solid, so by loss of electron, so it produces what? Zinc plus 2 aqueous solution, and it gives 2 electron. And next is what? This is called anodic reaction. This is called what? Anodic reaction. And next is what? Copper plus 2 in a aqueous solution, it gains what? Electron. So it produces what? It produces what? Solid copper. So this is called what? Cathodic reaction. So cathodic reaction. This is called what? Anodic reaction. Which is the anodic reaction? Zinc, the loss of electron is the anodic reaction, and the gain of electron, this is called what? This is called what? Cathodic reaction. So now overall cell reaction. Now I can write here overall cell reaction. Overall cell reaction. So what is this overall cell reaction? So zinc solid plus copper plus 2. This is what? Aqueous. So now it produces what? Now it produces what? Zn plus 2. This is what? Aqueous, plus of what? Copper solid. The plus of what? Copper solid. So this is called what? Overall cell reaction. This is the overall cell reaction. So this is the overall cell reaction. So here, so zinc by loss of electron, so the electrons are flows from what? Zinc electrode to what? Zinc electrode to what? Copper electrode. And the current is flows from what? The current is flows from what? Copper electrode to zinc electrode. So this is called what? The salt bridge. This is called what? The salt bridge. So this is nothing but a salt bridge. The salt bridge, it contains what? This is the salt bridge. This is nothing but a salt bridge. The salt bridge, it contains what? A saturated solution of what? Saturated solution of what? KCl. So this is the construction and the working of what? Electrochemical cell. In the examination, the 4 marks question, explain the construction and working of electrochemical cell. So how to take what? The Daniell cell. So first I have to explain the zinc electrode is dipped in 1 molar zinc sulfate solution. The copper electrode is dipped in what? 1 mole copper sulfate solution, and these two electrodes are separated what? Salt bridge. The salt bridge, it is a U-shaped having what? The saturated solution of what? KCl, and these two electrodes are connected to what? Emitter. So this zinc electrode is called what? Anodic half cell, where oxidation takes place, and the copper is called what? Cathodic half cell, where the reduction takes place. So now the anodic reaction, the zinc losses electron, so it produces zinc plus 2 electron, copper plus 2 aqueous 2 electrons, so it gives what? Solid copper. This is the overall cell reaction. So by this, so it produces voltage is equals to, it produces voltage is equals to 1.1 volt. So this is the construction and working of what electrochemical cell, that is what Daniell cell. Now is a cell representation. Next is the cell representation. Cell representation. Okay. Cell representation. The cell representation is here. So the zinc electrode is on left hand side. Zinc electrode is on left hand side. So I can write this is the zinc, and the zinc electrode is dipped in what? Zinc electrode is dipped in what? 1 molar copper sulfate solution. You write zinc sulfate, or simply how to write on Zn2 plus, and the salt bridge, and it is shown by what? These 2 lines. And next is what? The copper plus 2, and it is what? Copper. So while the cell representation, the metal is always at the extreme end. In general, suppose in general, so how do you represent cell? So first is what? M1 electrode is dipped in what? M1 solution, double line, this is the salt bridge. Next is what? This is what? M2 N plus, and this is what? M2. M1 and M2 are the metal is at the extreme end. So this is the cell representation. So this is the cell representation of what? This is the cell representation of what? Daniell cell, but this in general, so we can represent it. The next is what here? What is the E of cell? What is the E of cell? What is the E of cell? E of cell is equals to E of what? E of what? Right hand side electrode. E of what? Right hand side electrode, and E of what? Left hand side electrode. E of cell is equals to right hand side electrode minus left hand side electrode. Which is the right hand side electrode here? The copper is the right hand side electrode. So I can write E of what? E of what? Copper. So E of what? Copper. Okay. This I can take standard electrode potential E naught of copper. And which is the left hand side electrode? Zinc. So I can write what? E naught of what? E naught of what? Zinc. E naught of zinc. So now I can write this is the E of what? Cell. Next is E of cell. So what is the E naught of copper? What is the E naught of copper? The E naught of copper is always plus 0.34 volt. It is a 0.34 volt. Later I can discuss, okay, how it is 0. Now it is a 0.34 volt. Or okay, minus of what is the E naught of what? Zinc. The E naught of zinc is equals to minus of 0.76 volt. Yes, now I can write minus of 0.76. So now it is the voltage is equals to 1.1 volt. So this is called what? This is called what? E of or EMF of what? EMF of what? EMF of what? Daniell cell. The examination one more question. So calculate the EMF of Daniell cell. You take E of cell is equal to E of what? Right hand side electrode minus left hand side electrode. So which is the right hand side electrode? This is the copper. So it is the E naught of copper minus of E naught of zinc. So E naught of copper is nothing but standard electrode potential. It is always 0.34, and the standard electrode potential of zinc is what? Minus 0.76, minus into minus plus. So total the EMF of a cell is equals to 1.1 volt. But here the question is arises, what is the electrode potential? The question is arises, what is the electrode potential? Electrode potential. So the electrode potential is denoted by what symbol? This is what? E, electrode potential. What is the electrode potential? The potential difference. The potential difference. The potential difference develops. The potential difference develops between electrode and what? Electrolyte. Between electrode and what? Electrolyte. So is called what? Electrode potential. So what is the standard electrode potential? Yes, one more is the standard electrode potential. Standard electrode potential. The standard electrode potential is denoted by what? Is denoted by what symbol is E naught. So here the standard electrode potential of zinc, the standard electrode potential of zinc is equals to minus 0.76. The standard electrode potential of what? Copper is equals to 0.34. What is the standard electrode potential? when the electrode is dipped in a solution of its own ion. Zinc electrode is dipped in what? 1 molar zinc sulfate solution at a temperature of 298 Kelvin. It gives voltage, that is what? 0.76. So it is called what? Standard electrode potential. And what is the standard electrode potential of what? Copper. When the copper electrode is dipped in a solution of what? 1 molar concentration of what? Copper sulfate solution. So it gives electrode potential, that is called what? Standard electrode potential. Electrode potential means the potential difference develops between the electrode and electrolyte, zinc and zinc sulfate, copper and copper sulfate. If you want to calculate the standard electrode potential, say when the zinc electrode is dipped in a electrolyte solution of concentration 1 molar, so it is called what? Standard electrode potential. So standard electrode potential of copper, the standard electrode potential of copper is how much? 0.34 volt. What is the standard electrode potential of zinc? The standard electrode potential of zinc is 0.76 volt. Standard. What is the meaning of standard? The electrode potential of copper. The standard electrode potential of copper is 0.34 and the standard electrode potential of zinc is 0.76. Standard means when the electrode is dipped in a solution of water, the electrolyte having a concentration 1 mole, so it is called what? Standard electrode potential. Next is cell potential. Cell potential. What is the cell potential? Potential difference. The potential difference develops between two electrodes of what? Galvanic cell. Two electrodes of what? Galvanic cell is called cell potential. Is called what? Cell potential. Yes. What is the cell potential of Daniell cell or galvanic cell? So it is our example. Daniell cell is 1.1 volt. What is the cell potential? Potential difference develops between the two electrodes of what? Galvanic cell. So it is called what? Cell potential. The cell potential is difference of what? The difference of what? Electrode potential. Cell potential is the difference of what? Difference of electrode potential of anode and what? Anode and what? Cathode. Anode and what? Cathode. Anode and what? Cathode. The cell potential is the potential difference develops between what? Anode and what? Cathode. So it is called what? Cell potential, or it is also called what? EMF of a cell. What is the EMF of? Electromotive force. So this is called what? EMF of cell. Already we have discussed. What we have discussed? The zinc electrode is dipped in 1 molar zinc sulfate and the copper electrode is dipped in 1 molar copper sulfate. So when these two electrodes are connected, always it gives 1.1 volt. Here 3 cases are there. What is this? If external voltage is equals to 1.1 volt. For example, this is the external voltage. So this external voltage is equals to 1.1 volt. What happens? Here the first is no flow of electrons. No flow of electrons or no flow of what? Current. No flow of what? Current. No flow of what? Current. So this is the first. And no chemical reaction. No chemical reaction. No reactions takes place. So when the external voltage applied is equals to 1.1 volt. So this is the first case. The second case, if external voltage is less than 1.1 volt. For example, the same external voltage is less than 1.1 volt. Here what happens? A. Electron flows from zinc electrode to copper electrode, and current flows from copper to zinc. And the B is what here? Zinc dissolves at anode, and copper deposits at cathode. So this is the case 1 when external voltage equals to 1.1 volt, and the second case is if external voltage is less than 1.1 volt. And even the third case, what is this third case? I can discuss. What is the third case? Third case is what? If external voltage is greater than 1.1 volt. If external voltage is greater than 1.1 volt. Here what happens here? So here now I can write here. So if external voltage is greater than 1.1 volt. Here reverse means what? Here electron flows from copper to zinc, and current flows from zinc to copper. So this is what is the B? Yes, here zinc dissolves and copper the zinc deposited at zinc electrode, and copper dissolves at copper electrode. So these are the three cases when external voltage equals to 1.1 volt, external voltage is less than 1.1 volt, and external voltage is greater than 1.1 volt. Next is Nernst equation. Next is what? Nernst equation. Nernst equation for electrode reaction. Yes, I can write. This is the metal ion by adding n number of electron. Metal ion undergoes reduction. It gives what? Metal. So what is the? Yes, here E of cell is equals to, what is the Nernst equation? E of cell is equals to E naught of what? Cell minus of what? RT divided by what? NF. Now it is what? Ln of what? The concentration of what? Metal divided by what? Concentration of what? Mn plus. This is the concentration of Mn plus. Okay. So here the metal concentration M is taken as unity. Okay, what is the Faraday? When Faraday is equals to 96,500 coulomb. What is the R value? R value is equals to 8.314 joule per Kelvin per mole. So this is the universal gas. What is the temperature? The temperature is equals to 298 Kelvin. N is nothing but a change in oxidation number or valency. So now I can write here E of cell is equals to E of cell is equals to E naught of what cell. So now the land changes to what? Log. You have to multiply with 2.303. 2.303 RT divided by this is what NF into now log of what? Why it is log? Land changes to log, you have to multiply with 2.303. So the metal concentration is taken as a unity. So it is divided by what? Divided by Mn plus. Now E of cell is equals to E naught of what cell and 2.303 R value is 8.314. What is the temperature? 298 divided by N. What is the Faraday? Faraday is equals to 96,500. Now log of what? 1 divided by Mn plus. Now E of cell is equals to, so E naught of what cell? E naught of cell. So you have to multiply 2.303 into 8.314 into 298 divided by 96,500. So it gives 0.0591 divided by N. Log of what? Log of what? 1 divided by what? Mn plus. So this is the calculation of what? Electrode potential of what? The cell. So by using what? Nernst equation. Next, the Nernst equation is applied for what? Daniell cell. Daniell cell. Yes, what is Daniell cell? It consists of zinc electrode and copper electrode, and these two electrodes are separated by salt bridge. So what is the Daniell cell? In the Daniell cell, how can you calculate E of cell or EMF of a cell is equals to E of what? Copper and E of what? Zinc. E of copper minus E of zinc. Right hand side electrode minus what? Left hand side electrode. Yes. So now next the Nernst equation is applied for what? The electrode potential of copper. So E of copper is equals to E naught of what? Copper minus 0.0591 divided by N log of 1 divided by Cu plus 2. This is the equation number 1. This is for copper electrode. For zinc electrode, E of what? Zinc. E of what? Zinc is equals to E naught of what? Zinc minus of 0.0591 divided by N log of what? 1 divided by Zn plus 2. 1 divided by Zn plus 2. This is according to Nernst equation, which is applied for both copper electrode and zinc electrode. So what is the E of cell? E of cell is equals to E of copper minus of E of zinc. What is the E of copper? Yes, now I can write E of cell is equals to E of cell is, what is the E of copper? E of copper is equals to E naught of copper minus 0.0591 divided by N log of what? 1 divided by Cu plus 2. This is okay. Minus of what? Minus of what is the E naught of zinc? E naught of zinc, sorry, E of zinc is equals to E naught of zinc. E naught of zinc minus 0.0591 divided by N. Now log of what? 1 divided by Zn plus 2. Yes, this is the equation. Yes. Now E of cell is equals to E naught of what? Copper minus 0.0591 divided by N log of what? 1 divided by Cu plus 2 minus of what? E naught of what? Zinc minus into minus plus 0.0591 divided by N log of what? 1 divided by Zn plus 2. Okay, yes. Now here I can write. What is the E of cell? Same. E of what? Cell. So I can subtract E naught of copper E naught of copper minus of E naught of zinc. Okay, this is it. E naught of copper minus E naught of zinc, which is a common factor, minus 0.0591 divided by n, 0.05 by n. So, which is the plus 1 here? Yes, minus 1. First I can take here, yes, E of what is. Now I can take, this is the minus is what? Copper. 1 divided by log of what? 1 divided by Cu plus 2 minus of log of 1 divided by Zn plus 2, 1 divided by Zn plus 2, yes, minus of 0.591 log of 1 divided by Cu2 plus minus of what here, yes, minus of what, minus into minus plus 0.0591 divided by log of Zn plus 2, yes. Now I can write here E of cell. So this E naught of copper minus of E naught of zinc we can take as E naught of cell. We can take E naught of cell minus of 0.059 divided by n, 500 n. Now this is what log A minus log B, log A by B, yes, log of A minus log B, log A plus log of 1 divided by Cu plus 2 divided by log of what? Zn plus 2. This is a log A minus log B, log A by B. So now E of cell is equals to E naught of what cell minus of 0.0591 divided by n log, now I can write log of what? Log of what? Zn plus 2. Log of what? Zn plus 2 divided by copper plus 2. So this is the expression for the calculation of E of cell at a different concentration. So this is very important for examination point of view to calculate the EMF of cell of what? The 2 electrode system at a different concentration. Yes. Now the equation of what a Daniell cell is what? Now for example, second example, nickel solid is dipped in nickel plus 2. This is what? aqueous solution, and this is what? salt bridge. Now Ag plus, this is also aqueous, and this is what? Az. Nickel electrode is dipped in nickel plus 2 solution, and separated what? salt bridge, and the silver electrode is dipped in Ag plus. Write the cell reaction. One more question. Write the cell reaction. What is the cell reaction? First anode. First is what? Anode. Anode means what? Nickel solid by loss of electron, nickel plus 2 aqueous. This is what? Next, what is the cathode? What is the cathode? Cathodic ray. What is the Az plus? This is what? Az plus. This is what? Aqueous. So actually nickel gives 2 electrons, but Az plus takes 1 electron. You have to make it balance 2 electrons and 2 Az plus. So it gives what? It gives what? 2 Az solid. 2 Az solid. This is anodic reaction. This is cathodic reaction. What is the overall cell reaction? Overall cell reaction. Overall cell reaction. It is very important. One more question. What is the overall cell reaction? So here nickel solid plus of what? 2 Ag plus aqueous. Now it is what every day? Ni plus 2 aqueous, Ni plus 2 aqueous plus of what? 2 Ag solid. 2 Ag solid. This is the overall cell reaction. Write the E of cell of this. Write the Nernst equation. Nernst equation. Yes, Nernst equation of this cell. The examination one more question. Write the Nernst equation. With help of this, you have to write down. Ni is a left hand side electrode. Silver is a right hand side electrode. The nickel electrode is dipped in nickel solution, and silver electrode is dipped in silver solution. What is the Nernst equation? Nernst equation of this E of cell is equals to E of cell is equals to E naught of what cell minus of what 0.0591 divided by N. Yes, E of cell is equals to E naught of cell minus of 0.059 divided by N. And next is what? Log. So always you have to take oxidation half cell divided by reduction. Oxidation means which is the oxidation? Loss of electron is oxidation. And which is the reduction? Gain of electron. So while writing the Nernst equation, so first in the numerator you have to take oxidation half cell divided by reduction half cell. What is the oxidation? This is what? Ni plus 2. This is what? Ni plus 2 divided by what? Divided by what? Ag plus. This is what? Ag plus square. This is called what? Ag plus square. Why it is the Ag plus square? So it is a 2 square. And next, what is the N? N is nothing but a valency. How many electrons are lost or gained? So 2 electrons are lost simultaneously. The 2 electrons are gained. So what is the E of cell? So E of cell is equals to, so E naught of what? A cell minus of 0.059 1 divided by N is equals to 2. So log of what? Log of what? Ni plus 2. Log of what? Ni plus 2 divided by what? Divided by Ag plus square. So this is the equation. Yes. Second is equilibrium constant. Equilibrium constant. Equilibrium constant from Nernst, Nernst equation. The equilibrium constant from Nernst equation. For example, you know the Daniel cell. What is this Daniel cell? Zn solid plus copper plus 2 aqueous. So it gives rise to Zn plus 2 aqueous plus copper solid. So this is the overall cell reaction of what? Daniel cell. When the Daniel cell is what? If the Daniel cell is what? Is closed. Yes. So, zinc solid plus copper 2 plus aqueous, Zn plus 2 aqueous plus copper solid. So, this is the overall cell reaction of what? Daniel cell. If the circuit of this Daniel cell is what? Closed. So, what happens here? The concentration it changes as the time passes. If concentration of what? Zinc plus 2 keeps on increasing. If the concentration of zinc plus 2 keeps on increasing and the concentration of what? The concentration of what? Copper 2 plus keeps on decreasing. Decreasing. So if we observe this voltmeter, the cell potential is what? Decreases. If there is no change in concentration, of what? If there is no change in concentration of zinc plus 2 and what? Copper plus 2. If there is no change in concentration of what? Zinc plus 2 and copper plus 2, there is no change in what? Voltage. There is no change in what? Voltage. There is no change in voltage means 0. The voltage is 0. That is what? 0. So if the concentration of zinc plus 2 keeps on increasing and the concentration of copper 2 plus keeps on decreasing, so the voltage is also decreases. If there is no change in concentration of what? Zinc plus 2 and copper plus 2 ion, and there is no change in voltage means that is what? 0. It means equilibrium is reached. It means what? Equilibrium is what? Reached. It means the equilibrium is what? Reached. It is nothing but a E of cell is equals to 0. So according to the Nernst equation, what is the Nernst equation? E of cell is equals to E naught of what? Cell minus of what? minus of what? 2.303 RT divided by what? NF log of what? Log of what? Zn plus 2 divided by log of Zn plus 2 divided by what? Copper plus 2. E of cell is what? E of cell is what? 0. E of cell is 0 is equals to what? E naught of what cell minus. So this is what? 2.303 RT divided by what? NF, and now it is what? Log of what? Log of what? Zn plus 2 divided by what? Zn plus 2 divided by what? Copper plus 2. Now I can write here E naught of a cell, E naught of cell is equals to 2.303 RT divided by what? NF. Now it is what? Log of what? Log of what? Zn plus 2 divided by copper plus 2. Copper plus 2. So now at equilibrium, what happens? So Zn plus 2 divided by copper plus 2. Zn plus 2 divided by copper plus 2 is equals to what? Kc. At a temperature, at T is equals to what? T is equals to 298 Kelvin. Now E naught of cell is equals to, and you put 2.303, R value is 8.314, the temperature is what? 298 divided by Faraday is equals to 96,500, so it gives 0.0591 divided by N. This is of what? This is of what? Log of what? This is a log of what? Kc. This is a E naught of cell is equal to 0.0591 and divided by N log of what? Kc. This is the calculation of what? Equilibrium constant. The relation between the EMF of a standard EMF of a cell and the equilibrium constant is E naught of a cell is equals to 0.0591 divided by N log of what? Kc. Suppose if you want to calculate, if you want to calculate what the equilibrium constant of what? Equilibrium constant of what? A Daniell cell. You know that. What is the E naught of cell? What is the E naught of cell of Daniell cell is what? 1.1 volt. 1.1 volt. Now you have to put. So E naught of cell is equals to. Now I can write E naught of cell is equals to 1.1 into 0.0591 and N is equal to, N means what? Valence is what? 2, and now it is what? So E naught of cell is equals to 1.1 volt and 0.059 and N is equals to what? N is equals to what? 2. This is what? Log of what? Kc. Now the log of Kc is equals to 2 into 1.1 divided by 0.059, so we can get 37.28. Now log of Kc is equals to 37.28, so Kc is equals to NT log. Kc is equals to NT log of what? 37.28. Now Kc is equals to, Kc means what? Equilibrium constant S. So 0.28 NT log, this is we can get 2, and this is nothing but 37. It is almost 10 to the power of 30. This is the equilibrium constant of what? Daniell cell.